When designing ductwork, try to have fewer right angles in your duct system. Let me show you why. When designing ductwork, you want to direct the airflow where you want it to go. Air is stupid, and when it's going in a straight line, that's all it knows. And when you have a 90-degree angle that the airflow hits up against, it's going to bounce off of that. It's not going to go around the corner like you think it will. So anytime you have takeoffs on a duct system, you should use 45-degree angles that direct the air into the ducts that you're taking off from the main ductwork. This will alleviate any turbulence or recirculation of air in the duct system. When coming off a furnace or an air handler, this type of fitting is preferred compared to a T-type fitting where you have right angles that air is going to hit and bounce off of and recirculate and turbulate. So when designing your ductwork coming off of a furnace or an air handler, use a long radius type duct system that will direct the air out of the furnace or air handler and into the main ductwork. Whenever we're designing a system with a coil, we want to smooth out the airflow before it gets to the coil. So a transition, as much space as you can give us, will smooth the air out coming out of the air handler or furnace and completely bathe the evaporator coil in smooth, good air to get the highest efficiency we can out of that system. As we said before, air is stupid. And when you have a bullhead with no veins in it like this and a lot of right angles, air is going to come out of the furnace or air handler and hit the top of this ductwork and will rebound back into the furnace and cause turbulence and recirculation. By simply putting turning vanes into this type of a fitting, you're going to reduce the equivalent length from 120 feet down to 20 feet. Same thing applies to a downflow application with the same type of fitting. With the one with the right angles in it, you're going to have 120 equivalent length. And by putting turning vanes into that fitting, you're going to reduce the equivalent length to 20 feet, which is going to greatly reduce your external static pressure. So this type of fitting is most common on existing duct systems. And again, as the air comes out of the air handler or furnace, it'll hit the top of the ductwork, it'll recirculate and turbulate, and finally get down the ductwork. And at a 0.5 inch of water column external static pressure, this type of fitting adds to your ductwork 120 feet of equivalent length before you even get out of the equipment. So as we've stated, in your ductwork, we want to see the least amount of right angles as possible. We want to direct the air out of the furnace or air handler, and we want to direct the air into the expanding ducts off of the main branch. This will greatly reduce your external static pressure and give you the needed CFM to operate the system correctly.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.